You have only 15 months to build this mission. If you fail to launch on time, we lose the planetary alignment. Launch windows to Mars open only once every 26 months. You don't have a choice. Your rocket isn't powerful enough, but we still have to reach the red planet. Your spacecraft will travel in deep space. If its engine refuses to restart, the mission will be over. You are navigating a spacecraft millions of kilometers away. A mistake smaller than a fraction of a degree, and you miss an entire planet. No heavy lift rocket, no $1 billion budget. Only 15 months before the launch window disappeared. And a destination that had already defeated some of the world's most experienced space agencies. If you were an engineer sitting in that room, would you approve this mission? Because that's exactly the decision ISRO had to make. They didn't have the most powerful rocket, they didn't have unlimited resources, they didn't even have the luxury of time. Yet, 2 years later, India became the first nation in history to reach Mars successfully on its first attempt. But that success wasn't built on luck, it was built on hundreds of difficult decisions, relentless engineering, and one philosophy that changed everything. We have to reach Mars, whatever it takes. This is the untold story of Mangalyaan. In 2010, ISRO had every reason to focus on Chandrayaan 2. The moon mission was already on the roadmap. The technology was familiar and it was a safer choice. Then something unexpected happened. Inside ISRO, a different idea began to take shape. What if India skipped ahead and aimed for Mars? It sounded ambitious, maybe even unrealistic. Mars is nearly 225 million kilometers away from Earth on average. A spacecraft has to survive for months in deep space, navigate with extraordinary precision, and execute critical maneuvers, where even a small mistake can end the mission. But reaching Mars wasn't the only challenge. ISRO wasn't starting with a ready made Mars program. There was no spacecraft ready for an interplanetary journey, no launcher capable of sending it directly to Mars. Many systems, from onboard electronics and thermal protection to scientific instruments, had to be adapted, tested, and qualified for conditions India had never faced before. And the time was running out. The next Earth Mars launch window was in 2013. Miss it, and the opportunity wouldn't return for more than 2 years. According to the senior ISRO leaders, the success of Chandrayaan 1 gave the organization confidence that India was ready to attempt something bigger. ISRO chairman supported the proposal and the government of India approved the Mars mission with a budget of about $74 million, remarkably small for an interplanetary project. That single decision changed everything. ISRO had just over a year to build a spacecraft that didn't exist, for a journey India had never attempted, and with a budget that left almost no room for error. And the first obstacle was waiting on the launch pad. Imagine you are planning a road trip across states and realizing your car can't even leave the city. That's exactly where ISRO found itself in 2012. The government had already approved the mission, engineering teams were ready, countdown had begun, but there was just one problem. India didn't have the rocket needed to reach Mars. ISRO's idea was to launch Mangalyaan on their GSLV rocket, which was exactly what the mission needed, and was powerful enough to boost Mangalyaan out of the Earth's orbit and onto an interplanetary trajectory to the red planet. But GSLV suffered two failures in 2010, just as Mangalyaan project was being envisioned. Fixing the issues and preparing for another launch could have taken at least 3 years. ISRO didn't have the rocket and, most importantly, time. ISRO had only one practical option left with it: the PSLV rocket. But there was one problem with PSLV. It too couldn't reach Mars either, because PSLV was specifically designed for low orbit missions with less payload capacity. At this point, many of you may postpone the road trip. But no, ISRO did something else. ISRO team came up with the idea which perfectly portrays the frugal Indian mindset. They dropped the idea of building a bigger rocket. Instead, they asked, if we can't change the rocket, what if we change the journey? Many engineers were skeptical and asked, how will this happen? What the senior scientist explained will come next in the video, so keep watching till the end. Remember, you have planned a road trip and realized your car can't even leave the city. But now you also realize that you have very less budget for the trip. That's exactly what happened. For Mars Orbiter mission, the government of India approved a budget spends of 74 million US dollars. For most space organizations, that would have been the first reason not to go to Mars. At first glance, $74 million sounds like a huge amount. Until you realize you're trying to build a machine that has to travel more than 200 million kilometers away, survive in deep space, and enter the orbit of another planet. But ISRO engineers did something frugal. They didn't ask, how can we manage everything in this budget? Instead, they focused on, how do we spend smarter? So they didn't build a new rocket. They didn't build a new spacecraft platform. And they didn't overload the mission with dozens of scientific instruments. Instead, they spent money only where it increased the probability of mission success. They eliminated every unnecessary expense. Every week saved was money saved. And that mindset transformed $74 million from a limitation into one of ISRO's greatest engineering advantages. Building an entirely new spacecraft in 15 months for Mars was difficult. Building it with a limited budget was completely a different challenge. ISRO couldn't afford the luxury of designing everything from scratch. So, the engineers took hard engineering decisions that quietly shaped almost every part of Mangalyaan. Instead of creating an entirely new spacecraft, the team modified ISRO's proven I-1K spacecraft bus, the same engineering platform whose heritage came from earlier IRS, INSAT and Chandrayaan-1 missions. Its aluminium and carbon fiber composite structure was already flight tested. That meant engineers could spend their precious time solving Mars-specific problems instead of proving a brand new spacecraft. The spacecraft weighed 1337 kilograms at launch. But here's the surprising part. Nearly 850 kilograms of that was propellant alone, which meant the spacecraft itself, including its computers, antenna, scientific instruments, solar panels, structure and electronics, had to fit into water main. Every kilogram could create a chain reaction. More weight requires more fuel increases the spacecraft's mass, and a heavier spacecraft would push the PSLV beyond its capability. Engineers could have asked for dozens of instruments. Instead, ISRO selected 5 carefully chosen payloads. The goal wasn't to answer every scientific question about Mars. The goal was to demonstrate India's deep space capability while still producing meaningful science. That discipline kept the spacecraft lighter, simpler, and more affordable. At Mars, radio signals take several minutes to travel between Earth and the spacecraft. If something went wrong, engineers couldn't grab a joystick and fix it. So Mangalyaan had to think of itself. So engineers upgraded its onboard autonomy so the spacecraft could detect certain faults, protect itself, and continue operating until instructions arrived from Earth. A satellite around Earth experiences a very different environment from a spacecraft traveling to Mars. Sunlight becomes weaker as the spacecraft moves farther away. So, ISRO designed a 3 panel solar array capable of generating about 840 watts near Mars and paired it with a 36 Ah lithium ion battery for eclipse periods. Engineers also modified the spacecraft in areas that deep space mission demand most: communications, propulsion, power systems, and onboard autonomy, while relying on passive thermal control and multi-layer insulation to keep temperatures within safe limits, despite the harsh environment of space. Every major maneuver was rehearsed repeatedly on Earth. Navigation software, communication sequence, propulsion commands, and contingency procedures were simulated long before launch. Because once Mangalyaan left Earth, there would be no second attempt. Every line of code, every command, every calculation had to work the first time. By November 2013, ISRO hadn't built the most advanced spacecraft ever sent to Mars. It had built something arguably more difficult: a spacecraft where every kilogram, every watt, every component, and every rupee had been questioned before it was approved. But the biggest gamble was still waiting. For almost 300 days, the engine would remain silent, and when Mangalyaan finally reached Mars, that engine had to wake up on the very first attempt. Finally, 5th November 2013, the countdown reached zero. A column of fire erupted beneath the PSLV C-25. Slowly, almost reluctantly, the rocket lifted away from the Satish Dhawan Space Center, Sriharikota, India. For the next few minutes, millions of people watched the launch. Then, the rocket disappeared into the sky. For most of the world, the story had just ended, but for ISRO, it had only begun. The PSLV had done its job. It placed Mangalyaan into its initial Earth orbit. From the moment onward, the spacecraft was on its own. There would be no pilot, no steering wheel, no rescue mission. Only mathematics, physics, and years of engineering. Now, here comes the most fascinating moment. Remember, the senior scientist said, "If we can't change the rocket, what if we change the journey?" This is what he explained. PSLV was a small launcher and can't take the spacecraft out into deep space in one shot. It only had the power to carry Mangalyaan and drop it into Earth's initial orbit. Now the question is, how Mangalyaan would have reached Mars from Earth's initial orbit? So there lies a genius strategy. Instead of taking Mangalyaan in a single shot, the Mangalyaan used its own propulsion system in the Earth's initial orbit to boost itself into a higher orbit, and this happened again and again and again until break free of Earth's gravity. This strategy helped Mangalyaan pushing itself into higher loops and finally into deep space towards Mars, and saved a lot of fuel by using a series of carefully timed orbital boosts. It was roughly 25 days. ISRO carefully raised the spacecraft's orbit around the Earth through a series of 6 strategic orbit raising engine burns. Each burn added just enough energy to stretch the orbit farther from a planet, just like a slingshot. Finally, one last firing accelerated Mangalyaan beyond Earth's gravitational grip and onto its path towards the Mars successfully. Then came the longest phase of the mission, the cruise, nearly 300 days through deep space. At first glance, it looked as if nothing was happening. But inside mission control, every signal mattered. Every telemetry packet was examined. Every calculation was checked. Every subsystem was quietly proving that it could survive millions of kilometers from home. Even a tiny navigational error could become catastrophic. A deviation no wider than a human hair in the early trajectory could grow into hundreds of kilometers by the time the spacecraft reached Mars. That's why ISRO performed carefully planned trajectory correction maneuvers. Not because the mission had gone off course, but because precision leaves no room for assumption. As Mangalyaan traveled farther away, Earth became quieter. Radio signals took longer and longer to return. Mission control could no longer react instantly. Engineers had to think hours ahead, and the spacecraft had to think for itself. Day after day, week after week, month after month, Mangalyaan crossed the emptiness between two planets. Powered only by sunlight, guided by a group of stars, watched over by a team that could do a little more than calculate, wait and trust the engineering they had built. But while all this was happening, engineers were stressed of something more significant. 24th September 2014, 6:45 a.m. Inside ISRO's Mission Operation Complex at ISTRAC, Bangalore. No one was celebrating because after 15 months of engineering and nearly 300 days of traveling through deep space, the mission had reached its most dangerous moment. Ironically, reaching Mars was never the real challenge. The real challenge was reaching in Mars orbit. At that very moment, Mangalyaan was racing towards the planet at thousands of meters every second. If its velocity wasn't reduced with extraordinary precision, Mars would never capture the spacecraft. It could simply fly past the planet forever. One engine, one chance. Everything now depended on a single machine, the 440 Newton liquid apogee motor. But since leaving Earth, it had remained completely silent for almost 300 days. No engineer on Earth could guarantee how an engine would behave after months in the harsh environment of deep space. If the engine failed to restart, the mission would end within minutes. At 7:17 a.m. IST, the command sequence began. The 440 Newton engine ignited. For the next 23 minutes, the engine burned continuously. Every second reduced Mangalyaan's speed. Every second increased the pull of Mars gravity. By the end of every maneuver, the spacecraft had slowed by roughly 1.1 kilometers per second, just enough for Mars to capture it into orbit. Inside mission control, no one knew the outcome yet. Commands travel at the speed of light, but even light needs time. On that morning, radio signals took more than 12 minutes to travel one way between Mars and Earth. By the time engineers received confirmation, Mangalyaan had already completed the maneuver. There was nothing left to do except wait. The engine had performed exactly as planned. Mangalyaan was officially reached the orbit of the red planet. Applause erupted across mission control. Years of preparation, months of uncertainty, and 24 unforgettable minutes had rewritten India's place in the history of space exploration. Achieving this, India became the first nation ever to reach Mars successfully on its maiden attempt, and only the fourth space agency to place a spacecraft in Martian orbit. But perhaps the greatest achievement wasn't reaching Mars. It was proving that disciplined engineering, precise navigation, and thoughtful use of resources could accomplish what many believed required far greater budgets. As the applause echoed through ISRO's mission control, the news spread across the world. India had achieved what no nation had done before. a successful Mars mission on its very first attempt. But the celebrations inside Bangalore were only the beginning. Over the next few days, the entire world began asking a different question. How did ISRO achieve this? How had ISRO managed to execute an interplanetary mission with such disciplined planning, careful use of proven technology, and tight cost control? Mangalyaan became a case study discussed in engineering schools and management classrooms around the world. Mangalyaan was designed for a mission life for just 6 months. Instead, it kept working for more than 7 years. Long after completing its primary objectives, the spacecraft continued sending valuable scientific observations of Mars. Its Mars color camera captured global views of the planet, dust storms, and images of Mars' tiny moon Phobos, while other instruments studied the Martian atmosphere and surface. A mission built to prove technology ended up delivering years of science. One comparison appeared everywhere in the news: NASA versus ISRO. But that comparison missed the real story. NASA's Maven and ISRO's Mars orbiter mission had different scientific objectives, different payloads, and different budgets. They were never the direct competitors. In fact, while the media compared them, NASA's Deep Space Network worked alongside ISRO's Indian Deep Space Network to support communications with Mangalyaan. Space exploration wasn't a battle, it was also a collaboration. Every great mission has a name: Apollo, Voyager, Cassini, Mangalyaan. But missions don't dream, people do. Mangalyaan changed something much bigger than India's position in space. It changed the way people thought about innovation under constraints. The mission strengthened confidence inside ISRO and provided experience that flowed into future programs like Chandrayaan 2, Chandrayaan 3, and Aditya L1. Behind every trajectory, every calculation, every late night simulation, and every impossible deadline stood a team of Indian engineers who believed that limitations were not obstacles. They were design constraints waiting to be solved.
History has been created today. We have dared to reach out into the unknown and have achieved the near impossible. I congratulate all ISRO scientists as well as all my fellow Indians on this historic occasion. India has successfully reached Mars. आज मॉम का मंगल से मिलन हो गया।